Hey y'all, it's Miss Romprey. So anytime that you are using one of my tutorial videos to take notes, I always want you to pause in the beginning and go ahead and either A, copy your notes outline, or you could print it out from OneNote if you just want to print it and put it in your notebook. Or remember, you also have under your name in OneNote, if you click on your name, all of those pages that I've shared with you are editable. So you could even do a split screen on your computer and put your notes on one side and then put my video on the other. That way you could take notes like in live time while you're watching it. Whatever option seems easiest for you, that's what I want you guys to do, okay? So our first unit is all about expressions. So I want you to kind of think, what is an expression? Well, an easy way to think about it is comparing it. What's the difference between an expression and an equation? So what do y'all think? What's the difference between an expression and an equation? Well, let's start with the easy one, an equation. What do all equations have? An equal sign. So equations have an equal sign versus an expression which does not. So let's see, 7x plus 2. So 7x plus 2, that is an expression. Okay, it's got a couple of terms, but no equal sign. 7x plus 2 equals 9 turns that expression into an equation. So when topic 1 says using expressions to represent real-world situations, basically a word problem. So we're wanting to take a short little word problem and create an algebraic expression for it. Before we can do that, we really need to come up with what are some terms that we use that describe our operations. And when I'm saying operation, I mean addition, subtraction, multiplication, division. So I want you guys to go ahead and pause the video and come up with as many terms as you can for all of our four basic operations. So go ahead and pause the video, come up with as many as you can. I'm going to just give you a hint. I came up between like 4 and 8 for every word. I think division I could only come up with 4. So let me know if you have any new ones. But go ahead and pause the video and really think. Come up with as many terms as you can. Let's see what you can come up with. Alrighty, welcome back. So this is a good place for you to annotate your notes. So maybe the terms that you came up with could be in one color, and maybe any new ones or anything that stands out to you like, oh, I did not think of that, or oh, I don't even know what that one means. Well, maybe this is a good time for you to start annotating those notes. So either using a different color or highlighting. So let's go through a few. Now, addition, many of you probably came up with the basic ones like sum, plus, added to, okay? More than, that's a really good one that's used a lot. Couple that you might have missed, increase, okay? If we increase a number by 7, so we're adding 7. One that I really like is deposit, and that's in terms of banking. So if I deposit money, I am putting money into my bank, which is a good thing. Let's see, combine, if we combine something, that's a form of addition. And also total. Total likes to represent addition as well. Subtraction, let's see what you came up with. So I've got less than, fewer, I like fewer, 7 fewer than a number. Take away, minus, okay, those are all pretty basic. One you might not have thought of was remove. Okay. Let's see. Oh, diminish. If we diminish, we're taking away from something. So it's kind of another way to say take away. Again, my banking example, withdraw. So if we are withdrawing money, that means I am taking money out of my account. Hopefully for something good, not just for something boring like bills. Decrease and extract. I think I might have already said that. I don't know. But extract is to take out something. So that's a lot of words. a lot of terms just to represent, addition and subtraction. Multiplication and division I had a harder time with, so if you come up with any different ones, let me know. Multiplication, basic one, product, times, multiply by. Now some other ones that we like to use, doubling, tripling something, obviously multiplying by 2, multiplying by 3. Another good one somebody came up with was twice. I'm like, ooh, twice a number, 2 times a number. And then of. When of is used in word problems, it often represents multiplication as well. Now we also have division. And division, divided by, and quotient. Those are basic. Now, we also came up with split. Like if you split something, so splitting something down the middle, cutting it in half, which brings me to half, third, fourth, so dividing by 2, dividing by 3, dividing by 4. All of those are great. So if you come up with any other ones, definitely let me know and I will add them to the list. So anything that might have stood out to you, you might want to put in a different color or possibly highlight. Now this next section, like I said, we are taking on the left these phrases. These are all called verbal expressions because we're using word. So we want to take them and transition them into a mathematical expression or an algebraic expression. So if you think this is easy peasy, go ahead and pause the video and just come back and check your answers. If not, feel free to follow along with me, but I am definitely going to use my tools and either highlight or underline stuff like that. So 9 increased by a number. All right, keyword here, increased. So 9 increased by a number. So, 9 increased by, so plus a number. So do I know what that number is? So I'm going to assign a variable. So since it's number, I'm just going to say n. 9 plus n. Now, that is not the only correct answer. So in math, there are a lot of times where we are going to come up with things that can be represented in more than one way. So instead of 9 plus n, you absolutely could have had n plus 9. That is totally correct. Now, 14 decreased by a number. 14 decreased by a number. So what are we starting with? So we are starting with 14, and it is being decreased by a number. So we are taking away a number. So if you're getting confused, sometimes I like to put a number in. So let's say that number is 2. So what would 14 decreased by 2 be? Well, 14 minus 2. Does that make that easier? Maybe if you plug in a number. So 14 minus 2 would be 12. So I am decreasing by a number. So 14 and decreased by a number. So 14 minus n. Now, this is what I want you to think about. Can we rearrange those? Can we do n minus 14? Would that give us the same response? Well, plug it in. So how we said 14 minus 2? Well, switch that. Could we do 2 minus 14? So 14 minus 2 gives me 12. Is 2 minus 14 going to give me 12? Most certainly not. So this one cannot be rewritten, or it will not represent our verbal expression. All right, 7 less than a number. So 7 less than a number. Again, this is one that tends to catch people up, so I want you to think about it like plugging in numbers. So let's say 7 less than a number. So I'm going to say 10. So what's 7 less than 10? So hopefully you said 3. So 7 less than 10. Now, can I write, picking different numbers. So less than, minus. So 7 less than 10. 7 less, does that give me 3? For sure, no, that does not work. So when you see less than, that than tells you have to flip it. So the 7 actually has to go at the end. So 7 less than a number. We are taking 7 from a number. So whenever you see that than, you have to remember to flip. So that's what I'm telling you. Sometimes it's easier to use numbers, and then when you write your expression, if you were to plug in your numbers, see if it works. All right, the product. Product of 9 and a number. Product of 9 and a number. Well, product meaning multiplication. So we're going to multiply 9 and a number. So 9 times n. Now, do I have to put that little multiplication dot in there? Absolutely not. Multiplication is the one that we do not have to write the operation symbol. So 9n is an appropriate answer as well. All right, 32 divided by 32 divided by a number. I like division problems because you write them exactly as you read them. So we start off with 32, and we are dividing by a number. 32 divided by n. Easy peasy. All right, 5 more than twice a number. So again, what is that key word that I want you to look at? 5 more than twice a number. So this, when I see the than, I just want to get into the habit of writing more than, so plus. So 5 more than twice a number. Ooh, not just a number, but twice a number. So 5 more than 2n. 5 more than twice a number. Now, because this is addition, it absolutely can be written 5 plus 2n. That would absolutely be correct as well. However, if it was subtraction, it would be wrong if you switch those. So I just try and get in the habit when I see than to remember to write that first piece last. Just, again, so I don't forget when it comes to subtraction. If you've told me 5 plus 2n on an assessment, on a quiz or a test, absolutely, you would totally get it right. All right, the product. So we're back to product. What did I make product? Pink. So the product of a number and 6. So the product, so we're multiplying a number and 6. So 6n. Again, you could have used your multiplication operation like before. I just chose not to. So 7 divided by twice a number. Divided by, what I make that green? I know I use a lot of colors in my notes. I promise you'll get used to it. I just like colors. All right, so 7 divided by twice a number. So I begin with 7. Oh, I need to show you guys something. So I'm going to write it off to the side. So 7 divided by, so I'm going to use my division sign. So 7 divided by twice a number. Okay, I like to write division vertically. Now, if you decide to write it horizontally, and you do 7, and even if you do the division sign, which we don't really use much in algebra, most of the time we use, this is called a vinculum, the division symbol. But if I use that, 7 divided by 2n, there's a big thing here. That is not 7 divided by twice a number. That is the order of operations, division, then multiplication, because division came first. That would be 7 divided by 2, and then we would multiply that by a number. So I would need to put this in parentheses. So that's why I would just rather do this, so I don't have to think about that. Because especially if you had something like 2 plus n, or, I mean, they're operationally speaking, if you were to simplify it, if you don't put those parentheses, your actual answer, if you were to plug something in for n, it would be wrong. Ooh, I gotta hurry up. We're almost out of time. So go ahead and do these next two and then come and check your answer. All right, guys, thanks for joining. Let me know if you have any questions.